Hi students, welcome to lesson 37, Data Analysis, Approaches and Tools. Part A. We all know that data analysis is an extremely important stage in the research process leading to the consolidation of scientific knowledge. Data analysis is preceded by necessary steps and processes in the scientific approach. These include determination of research area, formulation of research objectives, appropriate methods of data collection and sampling techniques, etc. The efforts of the researcher can yield suitable results only with apt data analysis. This explains the criticality of data analysis. After completion of this lesson, you will be able to understand about data analysis approaches, differentiate between qualitative and quantitative data analysis. We will also know the computer aided tools for data analysis. Let us begin by understanding what is data analysis. Data analysis is defined as a process of cleaning, transforming and modeling data to discover useful information related with research theme. In most social research, the data analysis involves three major steps which we have briefly mentioned in the lesson Elements of Research. Let us further explore them. The steps are data preparation, which means cleaning and organizing the data for analysis. Descriptive statistics means describing the data. Inferential statistics means testing the hypothesis and models. Let us understand what is data preparation. Data preparation involves checking or logging the data in, checking the data for accuracy, entering the data into the computer, transforming the data and developing and documenting a database structure that integrates the various measures. Descriptive statistics is used to describe the basic features of the data in a study. They provide simple summaries about the sample and the measures. Together with simple graphic analysis, they form the basis of virtually every quantitative analysis of data. Descriptive statistics describe and present the data. They make no attempt to infer or predict population parameters. They are only concerned with data enumeration and organization, that is, they simply report what has been found using variety of ways. Descriptive statistics, therefore, are for summarizing quantitative data. They include frequencies, percentages and cross tabulations, measures of central tendency like mean, median, mode, measures of dispersion like standard deviation, taking stock, correlations and measures of association, partial correlations and reliability. Cross tabulation is another way in which one variable is presented in relation to another with relevant data placed into corresponding cells. It helps us to compare across groups and draw attention to certain factors. It also helps us to show trends or tendencies in the data. While descriptive statistics may be useful, inferential statistics are usually more valuable for researchers and are typically more powerful. Inferential statistics investigate questions, models and hypotheses. It seeks to make inferences and predictions based on the data collected. In many cases, the conclusions from inferential statistics extend beyond the immediate data alone. Inferential statistics helps to infer from the sample data. Inferential statistics is also used to make judgments of the probability that an observed difference between groups is a dependable one or one that might have happened by chance in the research study. Thus, we use inferential statistics to make inferences from our data to more general conditions. We use descriptive statistics simply to describe what's going on in our data. According to R.J. Shepard, an essential component of ensuring data integrity is the accurate and appropriate analysis of research findings. Improper statistical analysis distort scientific findings, mislead casual readers. The important considerations in data analysis include having the necessary skills to analyze, simultaneous selection of data collection methods and appropriate analysis, drawing unbiased inference. Further, following the acceptable norms for disciplines, determining statistical significance, contextual issues, data recording methods, reliability and validity are also important issues in data analysis. Dear students, let us understand the importance of hypothesis and algorithm in data analysis. Research questions or hypotheses guide the analysis of data. As we have already discussed in lesson on hypothesis, that hypothesis is an assumption about relationship between variables of the proposed research. The data collection instruments like questionnaires, interview guide, observation schedule, etc. must be developed according to hypothesis. With this understanding, data analysis starts with identifying which items on the instrument provides answer to which research question. Usually, two or more items on the instrument provides data to answer a research question depending on the complexity of the question. Therefore, the researcher identifies sections of the instrument providing appropriate data for each question. The concept of algorithm assumes significance in this context. Algorithm is based in the discipline of mathematics and computer science. It refers to a written, logical, step-by-step procedure or sequence of steps for solving a problem. Since data is collected to solve particular problems in form of research questions or hypotheses, it is suggested to write out a plan to carry out these operations or activities. Thus, as the research design is the master plan to conduct the research, algorithm serves as master plan or blueprint for data analysis. Algorithm gives a clear mental picture of how to analyze the data. Let us understand the analysis of quantitative data. After collecting quantitative data, there is a need to make sense of the responses collected by interpretation. This is done by organizing, summarizing and doing exploratory analysis. The meaning of the same is communicated through tables, graphical displays and summary statistics. Quantitative analysis helps us to see similarities and differences and the relationship between phenomena investigated, that is, the dimensions for which data has been collected. The analysis of quantitative data is generally called statistics. As K.F. Punch puts it, the essence of data analysis is to understand the logic behind the main statistical tools and the appreciation of how and when to use them in actual research questions. When we conduct quantitative research, finding evidence to either support or contradict an idea or hypothesis is of significant concern. We have discussed about hypothesis testing in the lesson Major Steps in Research. As you know, hypothesis testing, two types of hypothesis become important. Firstly, a null hypothesis which usually indicates no change or no effect. Secondly, an alternative hypothesis which is usually our experimental hypothesis. The evidence from the sample is taken to support either the null or alternative hypothesis. After null hypothesis is formulated, the level of significance, that is alpha level, is set. This is usually 0.05 for most social research, written as A is equal to 0.05. This means that for 95% of the time, the null hypothesis is not supported. This indicates the level of risk the researcher is willing to take in supporting or not supporting the null hypothesis. The succeeding stage involves computing the data using statistics in accordance to the research question. The final stage is to support or not to support the null hypothesis in light of the data analysis. Causal and associative hypothesis are two types of hypothesis which must be clarified in this context. Causal hypothesis suggests an input A will affect outcome B. An associative hypothesis, on the other hand, describes how variables may relate to each other but not necessarily in a causal manner. Hypothesis, causality, reliability and generalizability are significant aspects in quantitative data analysis. Causality refers to cause and effect, as the term suggests. Causality stems directly from three basic assumptions of the scientific method. They are order, determinism and discoverability. It shows how things come to be the way they are. Establishing cause and effect involves identifying variables which include independent, dependent and control variables. As you are aware, independent variable is the one that is deliberately manipulated by the researcher. Dependent variable is the one measured to determine the effect of the manipulated, that is independent variable. The control variables are those held constant during the experiment. It is assumed that independent variables have causal effect on dependent variables. Generalizability or external validity is the degree to which the findings of a study can be applied beyond the sample to the larger population. It presupposes that the study's findings can be generalized beyond the specific research. There are two aspects to generalizability: population validity and ecological validity. Population validity refers to the extent to which the findings can be applied to other people, while the ecological validity is about applicability of the findings to other settings. Quantitative researchers usually work towards producing generalizable findings. Reliability has to do with the consistency and dependency of a measure. It sometimes means that a reliable test should produce the same results on successive trials. By now, dear learners, you are familiar with the fact that statistical analysis could be univariate, bivariate or multivariate. We have discussed that univariate analysis examines the differences among cases within one variable. Bivariate analysis measures the relationship between two variables, while multivariate analysis looks for relationship between two or more variables. One-tailed and two-tailed tests are also important in statistical analysis. As we know, one-tailed tests predict that one group will score more highly than the other, whereas two-tailed test does not involve such prediction. One-tailed test is considered stronger than the two-tailed test because it makes assumptions about the population and the direction of the outcome. One-tailed test is used with directional hypotheses such as students who have studied psychology possess better stress management aptitude. On the other hand, a two-tailed test is used with a non-directional hypothesis such as there will be a difference in stress management aptitude of students who study psychology and those who do not study psychology. While the one-tailed test shows more or less, the two-tailed test only indicates a difference and not where the difference lies. Let us now understand about qualitative data analysis. Qualitative data analysis is the analysis of qualitative data such as text data from interview transcripts. Unlike quantitative analysis, which is statistics driven and largely dependent on the researcher, qualitative analysis is heavily dependent on the researcher's analytical and integrative skills and personal knowledge of the social context where the data is collected. The emphasis in qualitative analysis is sense making or understanding a phenomenon rather than predicting or explaining. A creative and investigative mindset is needed for qualitative analysis along with ethical considerations and participatory strategies. Sources of qualitative data include interviews, transcribed or they may not be transcribed, observation, field notes, documents and reports, memos, emails and online conversations, diaries, audio and video film materials, website data, advertisements and print material, pictures and photographs and artifacts. Analyzing the data collected through such methods is challenging but very interesting. One of the techniques for analyzing text data is grounded theory. It is an inductive technique of interpreting recorded data about a social phenomenon to build theories about that phenomenon. The technique was developed by Glaser and Strauss in 1967 in their method of constant comparative analysis of grounded theory research and further refined by Strauss and Corbin in 1990. It helped to further illustrate specific coding techniques. It is a process of classifying and categorizing text data segments into set of codes or concepts, categories that is constructs and relationships. The interpretations are grounded in or based on observed empirical data. To ensure that the theory is based solely on observed evidence, the grounded theory approach requires that researchers suspend any pre-existing theoretical expectations or biases before data analysis and let the data dictate the formulation of theory. Strauss and Corbin describe three coding techniques for analyzing text data. They are open, axial and selective. Open coding is a process aimed at identifying concepts or key ideas that are hidden within the textual data which are potentially related to phenomenon of interest. The researcher examines the raw textual data line by line to identify discrete events, incidents, ideas, actions, perceptions and interactions of relevance that are coded as concepts, hence called in vivo codes. Each concept is linked to specific portions of the text coding unit for later validation. Some concepts may be simple, clear and unambiguous, while others may be complex, ambiguous and viewed differently by different participants. The coding unit may vary with the concepts being extracted. Simple concepts may include just a few words of text, while complex ones may span several pages. Concepts can be named using the researcher's own naming convention or standardized labels taken from the research literature. Once a basic set of concepts are identified, these concepts can then be used to code the remainder of the data, while simultaneously looking for new concepts and refining the old concepts. While coding, it is important to identify the recognizable characteristics of each concept, such as its size, color or level, for example high or low, so that similar concepts can be grouped together later. This coding technique is called open because the researcher is open and actively seeking new concepts relevant to the phenomenon of interest. After this, similar concepts are grouped into higher order categories. While concepts may be context specific, categories tend to be broad and generalizable and ultimately evolve into constructs in a grounded theory. Categories are needed to reduce the number of concepts the researcher must work with and to build a big picture of the issues salient to understanding a social phenomenon. Categorization can be done in phases by combining concepts into subcategories and then subcategories into higher order categories. Constructs from the existing literature can be used to name these categories, particularly if the goal of the research is to extend current theories. However, caution must be taken while using existing constructs. As such, constructs may bring with them commonly held beliefs and biases. For each category, its characteristics or properties and dimensions of each characteristic should be identified. The dimension represents a value of a characteristic along a continuum. The second phase of grounded theory is axial coding, where the categories and subcategories are assembled into causal relationships or hypotheses that can tentatively explain the phenomenon of interest. The third phase is selective coding, which involves identifying a central category or a core variable and systematically and logically relating this central category to other categories. The central category can evolve from existing categories or can be higher order category that subsumes previously coded categories. Selective coding limits the range of analysis and makes it move fast. At the same time, the coder must watch out for other categories that may emerge from the new data that may be related to the phenomenon of interest, that is open coding, which may lead to further refinement of the initial theory. Hence, open, axial and selective coding may proceed simultaneously. Coding of new data and theory refinement continues until theoretical saturation is reached, that is, when additional data does not yield any marginal change in the core categories or the relationships. In order to identify key categories that are conditions, action or interactions and consequences of the core category, Strauss and Corbin recommend several integration techniques such as storylining, memoing or concept mapping. In storylining, categories and relationships are used to refine a story of the observed phenomenon. Memos are theorized write-ups of ideas about substantive concepts and their theoretically coded relationships as they evolve during grounded theory analysis. They are important tools to keep track of and refine ideas that develop during analysis. Memoing is the process of using these memos to discover patterns and relationships between categories using 2 by 2 tables, diagrams or figures or other illustrative displays. Concept mapping is a graphical representation of concepts and relationships between those concepts, for example, using boxes and arrows. The major concepts are typically laid out on one or more sheets of paper, blackboards or using graphical software programs linked to each other using arrows and readjusted to best fit the observed data. After a grounded theory is generated, it must be refined for internal consistency and logic. Researchers must ensure that the central construct has the stated characteristics and dimensions, and if not, the data analysis may be repeated. Researcher must then ensure that the characteristics and dimensions of all categories show variation. The theory must be validated by comparing it with raw data. If the theory contradicts with observed evidence, the coding process may be repeated to reconcile such contradictions or unexplained variations. Another method of qualitative data analysis is content analysis. It is the systematic analysis of the content of a text, for example, who says what, to whom, why and to what extent and with what effect in a quantitative or qualitative manner. When there are many texts to analyze, for example, newspaper stories, financial reports, blog postings, online reviews, etc., the research begins by sampling a selected set of texts from the population of texts for analysis. This process is not random, but instead texts that have more pertinent content should be chosen selectively. Then the researcher identifies and applies rules to divide each text into segments or chunks that can be treated as separate units of analysis. This process is called unitizing. Hermeneutic analysis is a special type of content analysis where the researcher tries to interpret the subjective meaning of a given text within its socio-historic context. Unlike grounded theory or content analysis, which ignores the context and meaning of text documents during the coding process, hermeneutic analysis is a truly interpretive technique for analyzing qualitative data. This method assumes that written texts narrate an author's experience within a socio-historic context and should be interpreted as such within that context. Broadly, the stages involved in analyzing qualitative data are: firstly, organizing the data; secondly, finding and organizing ideas and concepts; thirdly, building overarching themes in the data; fourthly, ensuring reliability and validity in the data analysis and in the findings; fifthly, finding possible and plausible explanations for findings; and sixthly, the final steps leading to interpretation of the data. We have discussed the differences between quantitative and qualitative research in the lesson Types of Research, Quantitative and Qualitative Research. Since there are clear distinctions between quantitative and qualitative research, the differences are also reflected in its data analysis as well. The significant differences between quantitative and qualitative analysis are: quantitative analysis quantifies data to test hypotheses or predict the future, whereas qualitative analysis seeks to get a deeper understanding of why certain things occur. In quantitative analysis, the sample is large and can represent the entire population, while the sample is small in qualitative analysis and cannot be used to represent the whole population. In quantitative analysis, the researcher conducts experiments, observations and measurements, whereas the researcher conducts interviews or surveys to collect qualitative data. In quantitative analysis, all measurable quantities such as density, length, size, weight is included, whereas typical data for analysis includes color, race, gender. In qualitative analysis, quantitative analysis is conclusive and objective, whereas qualitative analysis is exploratory and subjective.